In previous sessions, we already used queries and linked them to different visualizations: table, a chart, a state component. In this session, we'll take a closer look at the queries, what we can do with them, how to use them, what data is available, and so on. So let's start by creating our first query. So if you click the add, we'll have to name our query. So let's call it my query. And then we see in our first option here, we need to pick a data source. So queries basically allow you to play with different data sources in DataMiner. It allows you to filter them, to join them, to aggregate them, and so on. So what data sources are available, that depends a bit on the version you're running on. In this version, I have my elements as a data source, so basically an element list. I have 3 different ways to get access to my parameters, and I have a last option, which is a service list. In order to illustrate the different data sources of my query, I have linked a table visualization to my query, and that's a very useful visualization when working with queries, because it immediately shows you the output of the query, which is always a table. We have 5 data sources here. The elements and the services are very familiar, so let's get started with those. If we select get elements, we basically get an element table. So like you also have in Cube under your view cards. So it's a full element list with all the properties of your element, and the same goes for the services. But then, of course, the specific columns that apply to services and also the rows. Each service has a row, of course. For parameters, we have 3 different ways to get to the parameter data. Directly linking to one table from an element goes with the get parameter table by ID. We need to specify here in this version still the IDs, but later on you will be able to select a DataMiner element name. So that's an element from a Microsoft driver. So I have a task manager table in here. And you'll see the table is fully loaded with all its columns. Another way to get to the parameter data is getting parameter data from different elements together. So that's the option here, get parameters from elements where. Here I have 2 options to make a selection of my elements. I can do that by protocol, and that's the most straightforward one. So let's start with that. If I, for example, select the Nimbra protocol and version, I can specify 1 or multiple standalone parameters, for example, and then I get those values from the different elements. You can compare this with what we have with the pivot table. But instead of selecting standalone parameters, I can also take a table. And then all the rows from the different tables, from the different elements, are combined into one view. Next to the protocol, we can also specify elements based on a profile definition. Let's do that. What I have done here, I have created profile definition in DataMiner Cube that holds 2 parameters. It's the system uptime, the last boot uptime, and the system uptime, sorry. And I have linked that profile definition to 2 protocols. So first of all, my Nimbra nodes are linked to that profile definition, and also my Microsoft platform is also linked to those profile parameters. So when having selected this profile definition, you can see that I have a list with the 2 parameters and their value for all the elements. A final way to get to the parameter table is an optional one. It's only available if you have drivers in your data miner cluster which offload their data directly to Elastic. If you do that, you can create aliases in Elastic, and if you have those aliases, they are available over here, so we can also integrate them in your queries. I have in my DMS here drivers that offload OTT data to the Elastic database, so I can access that data and visualize it also here in my table visualization. And that's it for the data sources. In order to illustrate the different operation, I have prepared here one query. The query results in a task manager from all my servers, all together in one list. I've done that by selecting get parameters from elements where data source, type is protocol, and then I've specified the protocol and the parameter task manager. Going to the next line, I can see I get different options. Looking at the most basic option is the select here, where I can basically select some of the columns. So let's take virtual memory, CPU, the name and the element ID, and then you see the query results in a table with less columns. Continuing with that, I can see in the next line I get the same options again. But besides selecting columns, I can also filter my rows. So for example, I can select CPU to filter. I can choose to say, okay, I want the CPU greater than 0, for example. Let's see what that gives. And then we see a row filter is applied to our list here. Besides filtering rows and columns, we can also create new columns. We can do that with column manipulations. There are two manipulation methods. The first one is concatenate. In here we can take one or more columns and specify via a format and a new column name a new column. So we can see we can use the bracket syntax, familiar with what we have in the C#. Let's call this column name full ID. We see here that we have a new column added in our table with, which starts with the name of the process and then between brackets the ID, so in the format that I have specified over here. The other column manipulation is the regex match. In here we take one of the columns to start from. We fill in a regex, so in here I will try to take everything behind the slash, so the element ID is the data miner ID / element ID, and what I want here in this new column is only the element ID. So I'll give that a name, pure element ID. And again, we see a new column appearing with indeed the regex result of the regex I have filled in here. Another option in our query is the topx. In the topx, you can specify one of your columns. Let's, for example, take CPU. And if we make x10, we basically create a top 10 of our CPU usages across all processes of all elements. There is also an option here to create the bottom x. One of our most powerful operations is the join operation, where we basically combine two tables together. We have 4 different types: in inner, left, outer, and right join. You can compare it with the join operations you also have on database languages. So an inner join combines the keys that have a match in the left and the right table. A left join only holds the keys from the left table, right only from the right, and the outer join combines the matches from the left and the right together. Let's take a left join here and try to join this table with some element information. So we already have the element ID here in this list, but now I want to join this nice table with some more details of the element list. You see here that we have a new branch. So basically we start here from a new data source. And if we take the elements and select a subset of the columns, do not overload our table here. Just picking the ID and the name, because it's the name that I am interested in. And if we complete the join by making the link, so I specify here the element ID on the left with the element ID on the right table. Applying that, we see that we have two new columns. So we have the element ID now also from the right table together with the name. And that's the part we are interested in, of course. Last but not least, we have our final operation, and that's the aggregate. Again, we need to specify a column. So we'll take a CPU again. And we can apply different aggregations. So we have the average, the count, and distinct count, minimum and maximum, medium, percentile operations, standard deviation, and a sum. Let's illustrate this with an average. So I have one result as output, and that's the average CPU of all my items that match in my query up to now. In order to illustrate the aggregation further, I've created another example here. And here I list the total processor load for all my servers together with the name of their operating system. If I want to aggregate total processor load now, take for example the maximum. I have a new option in here, group by, in which I can specify one of the other columns. I take the operating system name. I have my maximum value per value of the operating system. I've cleaned up some space to illustrate the other visualizations for our query. And that's first of all state component. If we link that, we see the same values over here. Secondly, we have charts. A bar chart, for example. If we link it, we still need to configure the label and the bars. So in here we have a nice graph visualization of our query. Then also a pie chart is possible. Link it to the query, and then in the settings configure the label and the segments.